We are going to explore the algebra of functions. And our goal here is to create new functions from old functions. We're going to do that by finding the sum of functions to create a new function, the difference of two functions to create a new function, the product of two functions, the quotient of two functions, and lastly, the composition of two functions. In this video, we're only going to tackle the sum and difference of two functions to create a new function. All right, what we're going to need is first to have kind of our players. So we are going to let f and g be two functions. So these are our old ones. So they're going to be our two functions. And we are also going to let p be equal to the domain of f and q equals the domain of g. So I don't know what is in those domains for this particular function, for these particular functions, but we're just going to call it p and q respectively. Okay, so p contains all the elements that I can legally plug into f, and q contains all the elements I can legally plug into g. All right, we are going to define h of x to be equal to the sum of f and g. And the way we actually evaluate h at x is to evaluate it at f and evaluate it at g, and then add those two pieces together. And that's pretty simple. We'll look at an example here in a minute. What can be tricky is talking about the domain of h. But it's not too tricky. Let's think about it. We know that when we plug any value into h, we are going to be plugging it into f, so it must satisfy the domain of f, and then we're going to plug it into g, so it must also satisfy the domain of g. Okay? So whatever goes in h must be able to go into both f and g. So it needs to be in the intersection of their domains. Okay? And that's exactly what it is. The domain of the sum of two functions, so f plus g of x, is equal to p intersect q. All right? So that means the elements that are in both the domains of f and g. So the elements in their each domains that they share in common, that's in the domain of the sum. Okay? Likewise, we can define, let's get rid of that, function, you could say t of x to be equal to the difference of our two functions. And the way we evaluate t of x is we evaluate f of x, and then we subtract off g evaluated at x. So just like before, whatever goes into t has to be able to go into both f and g. So the domain of the difference of two functions is the intersection of the domains of each our original functions. Let's look at an example to help illustrate. Okay? Let's say that f of x equals 2x minus 1, and g of x equals the square root of x minus 1. Let's first consider the domains of f and g. We now know, so we'll call p the domain of f and q the domain of g. We know that f is a polynomial, and we know that that means the domain of p is the domain of f, which is p, all real numbers. We know that's true for all polynomials. Q is our g is our radical function, so we know that to find the domain of g, or to find q, we need to find all x values such that x such that x minus 1 is greater than or equal to 0. And that's true when x is greater than or equal to 1. So Q, or the domain of G, is x greater than or equal to 1. All right? So, what is h of x? Let's scoot this up. If h of x is equal to f plus g of x, then that tells us that it's equal to f of x plus g of x, which is equal to 2x minus 1, because that's what f of x is, plus the square root of x minus 1. That is our new function h. We could combine these if we had like terms, but we don't, so we can't. So what is the domain of h of x? Well, remember, it has to be the intersection of both f and g. Well, since p is all real numbers, and q is all real numbers greater than or equal to 1, the only ones they share in common are the ones that are greater than or equal to 1. So the domain here is x greater than or equal to 1. Okay? Now let's define the difference of these two particular functions. So let's see if we can still keep that in view. So we'll say t of x is equal to f minus g of x, which is equal to 2x minus 1. So there's my f of x minus the square root of x minus 1. And there's my g of x. So t of x is equal to this function, and guess what? The domain is also x greater than or equal to 1. Now let's evaluate finding the sum of two functions from a graph. So let's say this is our graph of our two functions. The top one is f and this bottom one is g. And let's see what it would mean to sum up, or to define the sum of these two functions. Okay? So I'm going to put this paper here for just a second, and then we will move it as we need to see it. So if we let h of x be equal to f plus g of x, we know that's equal to f of x plus g of x. Okay? So what if we want to find h of negative 8? Okay? Well, that's going to be equal to f of negative 8 plus g of negative 8. All right? So we come down here and we look at our graph and we say, well, what is f of negative 8? We come over here to negative 8 on our x-axis and we go all the way up and we see that f is equal to 9 when x is equal to negative 8. So f of negative 8 is 9. Now we do the same thing with g. So we still go over to negative 8 on the x-axis. This time we go up to where it hits g, which is 7. So g of negative 8 is 7. So h of negative 8 is 9 plus 7, which is 16. Lastly, if we wanted to define t of x to be equal to f minus g of x, we would separate them by their differences. And if I wanted to find t of negative 8, well, this time I would know it would be 9 minus 7, which is 2. And that's how we find the sum and difference of two functions, both algebraically and graphically.